How did a people living in the harshest climates of Northern Europe manage to build homes that could withstand storms, relentless winds, and heavy snow without a single nail or a drop of cement? The answer lies not in modern technology, but in the ingenuity, observation, and traditions passed down through generations. For the Vikings, shelter was not merely a convenience. It was a matter of survival, a fortress against the fury of nature that could sweep across the fjords and forests with little warning. Every detail, from the placement of beams to the choice of materials, reflected a profound understanding of the environment, a harmony between architecture and the natural world that modern builders are only beginning to appreciate. As dawn breaks over a snow-dusted Scandinavian coastline, one can almost picture the bustling activity of a Viking settlement. Smoke curls gently from the chimneys of longhouses, the timber walls standing resolute against the wind that sweeps down from nearby mountains. From the outside, these homes appear simple, even modest, rectangular structures with pitched roofs and minimal decoration. But within this simplicity lies a sophisticated design, honed over centuries to endure the elements. The first secret to Viking durability was timber selection. The Norsemen knew their forests intimately, understanding which trees offered strength, flexibility, and longevity. Oak, with its dense fibers, provided the backbone for structural beams, while pine and spruce, lighter yet resilient, formed walls and roofing elements. But timber alone was not enough. The Vikings understood the natural tendencies of wood, how it bends under weight, how it reacts to moisture, and how it expands or contracts with the seasons. Rather than fighting these natural movements, they designed homes that could absorb and adapt to them. A longhouse's skeleton was made of massive vertical posts, often embedded deep into the ground to anchor the structure. These posts were not carved to fit, but shaped to accommodate one another. Horizontal beams carefully notched, slotted into vertical supports, creating a network of interlocking joints. It was a form of construction that demanded precision, for each beam had to bear weight and transfer force in harmony with its neighbors. There were no nails, because nails can split timber and fail under extreme pressure. Instead, Vikings used wooden pegs, strong tapered dowels that locked beams together without damaging the wood. The pegs could flex slightly under stress, giving the walls and roof a subtle resilience. The walls themselves were another feat of engineering. Vikings often used a technique called post and wattle, weaving branches or thin strips of wood between upright posts to form a lattice. This lattice was then coated with a mixture of clay, straw, and animal hair, forming a plaster-like surface that sealed gaps and insulated the interior. In some coastal settlements where clay was abundant, they relied on thick mud walls, while in forested highlands, wooden planks overlapped in a horizontal shingle pattern to deflect rain and snow. Every solution was context-specific, demonstrating the Vikings' deep understanding of their landscape. Roofs, the most exposed part of any building, were designed with both function and environment in mind. Most longhouses featured steeply pitched roofs, allowing snow to slide off rather than accumulate. The frames were built with heavy crossbeams, forming triangles that could resist both vertical loads from snow and lateral pressures from wind. Thatch, turf, or wooden shingles covered these frames, materials chosen for their insulation and weight. Heavy roofs pressed down on the walls, stabilizing the structure while simultaneously shedding water. In winter, the extra weight of snow actually reinforced the interlocking beams, compressing the house into a firmer, more storm-resistant shell. But the genius of Viking architecture was not limited to materials and shapes. Placement was equally critical. Homes were rarely constructed haphazardly on a plot of land. Builders studied the wind patterns, the slope of the terrain, and the proximity of water. Villages often clustered homes together, sharing walls or placing structures close enough to break the force of wind. In many settlements, homes were oriented with their narrow ends facing prevailing winds, reducing the surface area exposed to storm gusts. Natural windbreaks such as hills, dense forest patches, or rocky outcrops were incorporated into the village plan, demonstrating a level of environmental engineering centuries ahead of its time. Inside, the Viking home reflected a marriage of practicality and social function. The central hearth, often located mid-house, radiated warmth efficiently, with smoke channeled through a roof opening. Floors were slightly raised in areas to prevent moisture damage, while storage spaces kept food, tools, and clothing off. Damp ground. Every beam and post was multifunctional, supporting weight, dividing space, and sometimes even acting as a perch for birds or a shelf for drying herbs. This efficiency of design reduced the need for additional fasteners or complicated fixtures, allowing the house to breathe, expand, and contract naturally. A particularly remarkable aspect of these homes was their flexibility. Unlike rigid modern constructions, Viking longhouses were designed to endure movement. Timber framing allowed slight shifts during storms, absorbing the energy that might otherwise crack stone or brick. This gave the houses a remarkable longevity, with some foundations still visible in Scandinavia today. It also reflects a philosophy that seems counterintuitive in an age of rigid engineering. Rather than resisting nature, these builders accommodated it. Even small architectural details were considered. Windows were minimal and small, often just openings covered with animal hide or thinly stretched. Horn, reducing drafts. Doors were thick, made from planks reinforced with horizontal beams, and often slightly elevated from the ground to prevent water damage. The simplicity of these features belied the careful calculation behind them. Every opening was a potential weakness in a storm, and Vikings treated it accordingly, balancing light and ventilation with structural integrity. Yet, no discussion of Viking homes is complete without considering the communal knowledge that made this construction possible. Unlike modern architects, Vikings rarely relied on written blueprints. Skills were transmitted orally, from parent to child, master to apprentice, with each generation refining techniques through trial, observation, and adaptation. A builder could look at the local trees, feel the grain, and intuitively know which branch would make the best joint. Patterns of weather and soil conditions were memorized, creating an experiential library that guided construction choices. In this sense, every home was a collaboration between human skill, collective memory, and environmental wisdom. One of the most striking examples of Viking ingenuity is the concept of the windbreak farmstead. By arranging buildings strategically, Vikings created microclimates that protected livestock, stored grain, and minimized heat loss. Houses might be staggered, with barns and storage sheds forming a protective barrier around the main dwelling. The careful positioning of fences, walls, and even rows of trees could reduce wind speed by half or more, a subtle but life-saving measure during northern gales. Such designs reveal a holistic approach to architecture. The home was not isolated, but integrated into the landscape and social network. And yet, for all their technical mastery, Viking homes were also a reflection of culture and identity. Carvings on beams, symbolic placements of posts, and patterns in roof turf told stories of family lineage, local myths, and religious beliefs. Functionality and aesthetics were not separate. The very act of building was a statement of belonging, resilience, and respect for the natural order. To step into a Viking longhouse was to enter a space shaped by necessity, artistry, and generations of experience. A space that could shelter families through winter storms, fierce winds, and even raids, all without a single nail or ounce of cement. It is tempting to view such architecture as primitive, yet the more closely we examine it, the more we recognize its sophistication. The Viking approach challenges modern assumptions about strength and durability, suggesting that flexibility, integration with nature, and deep empirical knowledge can be more effective than brute materials or mechanical fixings. In many ways, the lessons embedded in these structures are still relevant today, particularly as architects and engineers seek sustainable methods of building resilient homes in challenging environments. Imagine now a storm rolling in over a coastal village. Rain lashes the walls, snow whips across the rooftops, and gusts threaten to topple lesser structures. Inside, the longhouse endures. The timber flexes but holds, the roof channels water efficiently, and the walls, built with an understanding of both physics and material behavior, remain intact. Smoke continues to rise from the hearth, the interior remains warm, and the family sleeps safely through the night. This resilience was not accidental. It was the product of centuries of observation, trial, and cultural transmission, a remarkable achievement for a civilization often remembered only for raiding and conquest. But how did this knowledge evolve? How did a society without modern science or formal engineering develop such a reliable system of construction? To answer this, one must look beyond the home itself and into the broader context of Viking life. Survival in northern latitudes required adaptability. Communities faced harsh winters, scarce resources, and unpredictable weather. Mistakes could be fatal. Each failed roof or collapsed wall was a lesson shared across families and settlements. Over generations, these lessons crystallized into design principles that were remarkably consistent across vast distances, from the fjords of Norway to the river valleys of Sweden and Denmark. Even the seasonal rhythm of Viking life influenced home construction. In the summer, builders would fell trees, shape beams, and prepare materials while the weather permitted. In winter, when the ground was frozen, houses were insulated and maintained. This cyclical approach allowed a balance between labor availability and environmental conditions, maximizing the durability of the structures and minimizing the risk of error. It was a form of project management guided entirely by nature's timetable, yet astonishingly effective. The homes of the Vikings were not merely shelters, they were expressions of a people's understanding of their world. Every joint, post, and wall spoke of experience, adaptation, and foresight. While modern audiences may marvel at their raids and ships, the quiet genius of their architecture offers lessons equally profound. That resilience can be achieved through observation and adaptability, that strength does not always require rigid materials, and that harmony with one's environment can produce results far beyond what force alone can accomplish. And so, as the camera pans over a recreated village at twilight, smoke rising gently, wind stirring the trees, one begins to see the invisible threads connecting each beam and wall, a story of survival, intelligence, and cultural continuity. These homes endured because they were designed not just for living, but for understanding, anticipating, and withstanding the natural world. It is this principle that would allow the Vikings not only to survive in one of the harshest regions of Europe, but to thrive, expand, and leave a legacy whose echoes still resonate in the forests and fjords of Scandinavia today. In the coming centuries, many would attempt to replicate their durability, yet few could match the combination of simplicity, flexibility, and environmental wisdom that characterized Viking construction. As the storm begins to rise over the coast, lashing waves against the shore, the longhouses stand firm, silent testaments to a civilization whose architects understood the most elemental truth of all. Nature can be endured, but only if it is first understood. The foundations of Viking homes reveal another layer of their ingenuity. Builders often dug post holes deep into the ground, sometimes lined with stones to prevent rotting and shifting. The soil itself was studied carefully, and certain types of clay or compacted earth were preferred for supporting weight. In areas prone to flooding or heavy snow accumulation, timber platforms elevated the entire structure, creating a natural barrier against moisture and decay. These foundations were not hidden or purely functional. They were integral to the house's ability to survive centuries of harsh northern weather. The floor plan of a longhouse was deliberately simple, yet highly functional. Rectangular in shape, it allowed even distribution of weight from the roof and walls. Central to the interior was the hearth, where fires burned day and night, not only providing warmth but also serving as the focal point for family life. Smoke was managed carefully. While some longhouses had rudimentary chimneys, many relied on an open roof vent. The placement of this vent was critical, ensuring smoke could escape efficiently without allowing excessive cold air to enter. Hearths were surrounded by raised areas or stone slabs, protecting floors from heat and keeping living spaces slightly elevated above ground moisture. Walls, though appearing uniform, were composed of multiple layers designed to maximize insulation and structural integrity. The outer lattice of wood was sometimes reinforced with additional planks or beams, creating a layered defense against wind and rain. Between these layers, Vikings might pack moss, straw, or wool, taking advantage of local materials for their insulating properties. This combination allowed walls to breathe, reducing the risk of rot while keeping interiors warm. The thickness of walls varied according to regional climate. In the northernmost settlements, walls were substantial, designed to resist sub-zero temperatures, while milder regions favored lighter construction to allow ventilation during warmer months. Roofs remained one of the most remarkable features. Viking builders understood that the roof was not merely a cover but a structural element that held the home together. Roof beams were often carved with precision, sometimes angled to accommodate heavy turf or thatch. In regions with abundant forests, wooden shingles were meticulously arranged in overlapping layers, shedding water and snow efficiently. Turf roofs, while heavier, provided superior insulation. The grass and soil absorbed rainfall, slowed heat loss, and added mass to stabilize the structure during storms. Over time, the weight of snow pressing on the roof actually strengthened the joints, a natural adaptation that illustrates the Vikings' understanding of material behavior under stress. The joinery techniques used in these homes were particularly sophisticated. Mortise and tenon joints, where a projecting tenon on one beam fits snugly into a corresponding mortise, formed the backbone of the framework. Wooden pegs driven through these joints locked them in place without the need for metal fasteners. This method allowed the timber to flex slightly under pressure, a subtle resilience that metal nails could not provide. Even when faced with heavy storms or snow accumulation, the structure could move as a whole without splitting or collapsing. Inside, every element of the home served multiple purposes. Benches along walls provided seating and storage. Shelves and racks held tools, food, and textiles, keeping them off damp floors. The placement of posts and beams was both structural and functional, allowing for hanging meat, drying fish, or even supporting lofted sleeping areas. Every component was designed to maximize utility while minimizing the need for additional fasteners or supports, reflecting a resourcefulness born of necessity. Windows, small and rare, were treated with the same care. When light was needed, Vikings used translucent animal horn or thinly stretched hide, materials that allowed light in without compromising insulation. The small size of these openings minimized heat loss and preserved the structural integrity of the walls. Doors were thick and tightly fitted, often slightly elevated to prevent water from seeping in. The simplicity of these features belied the careful planning behind them, balancing human comfort with resilience against the elements. Beyond individual homes, the layout of Viking settlements contributed significantly to their durability. Homes were rarely isolated. Villages were compact, often clustered around a central hall or communal space. This arrangement created shared windbreaks, reducing the impact of storms on any single structure. Barns, granaries, and workshops were strategically placed, sometimes forming a perimeter that protected more delicate buildings at the center. Trees, fences, and natural ridges were incorporated into the settlement plan, demonstrating a sophisticated understanding of environmental engineering. One particularly effective strategy was the use of staggered roofs. In some villages, the longhouses were not aligned perfectly, instead their roofs were offset slightly. This disrupted wind patterns, preventing gusts from striking multiple buildings at once. The result was a microclimate within the village that protected inhabitants, livestock, and stored crops. Such subtle adjustments, born from centuries of observation and trial, underscore the Vikings' intuitive approach to construction, an approach rooted in adaptation rather than conquest. The choice of construction materials reflected both availability and performance. Oak, dense and resilient, was reserved for load-bearing beams, while pine and spruce were used for walls and roofing. Moss, straw, and clay filled gaps and added insulation. Turf roofs, sometimes several feet thick, acted as living insulation, absorbing precipitation while regulating temperature. In coastal regions where wind and salt spray were persistent threats, builders often treated timber with animal fats or tar, extending its life and resistance to decay. Every material had a purpose, and every choice reflected an understanding of both local resources and environmental challenges. Viking homes also adapted to the rhythm of the seasons. In summer, maintenance and construction projects were undertaken when ground conditions and weather permitted. Timber was cut, dried, and shaped carefully, ensuring it would perform optimally during winter. During harsh months, focus shifted to upkeep and survival, repairing minor damage, managing smoke vents, and ensuring the hearth remained efficient. This cyclical approach allowed Viking builders to maximize both labor efficiency and structural longevity, integrating construction into the broader seasonal life of the community. Communal knowledge played a central role in the success of Viking architecture. Skills were transmitted orally from parent to child, master to apprentice. There were no blueprints or formal manuals, yet every builder understood fundamental principles of weight distribution, joint integrity, and environmental adaptation. The hands-on training emphasized observation and problem solving. A novice might spend years learning to read the grain of timber, predict its behavior, and shape it into a reliable beam. Each completed house became both a shelter and a teaching tool, a repository of experience for the next generation. Even minor details were carefully considered. Smoke holes were positioned to optimize ventilation without creating drafts. Doorways were sometimes slightly offset to reduce wind penetration. Roof overhangs protected walls from rain, while turf layers on roofs moderated indoor temperature. Every component of a longhouse contributed to the overall resilience, reflecting a holistic approach that combined architecture, environmental science, and social organization. The Vikings' attention to detail extended beyond the home itself. Storage buildings for grain and livestock were designed with the same principles of resilience and insulation. Granaries were elevated on posts to prevent moisture and rodent damage. Animal shelters were positioned to take advantage of windbreaks, ensuring that livestock could survive the coldest months. The interdependence of structures within a settlement created a system in which homes, storage, and livestock areas supported each other, reinforcing the community's survival strategy. Despite their apparent simplicity, Viking homes were remarkably versatile. They accommodated changing family sizes, seasonal fluctuations in population, and even temporary guests or raiding parties. Interior partitions could be adjusted with movable screens or curtains, while lofted areas provided additional sleeping or storage space. This adaptability was achieved without complex hardware or nails, relying instead on careful planning, joinery, and spatial understanding. The aesthetic aspects of Viking architecture were subtle but significant. Carvings on beams, roof edges, and posts often conveyed cultural symbols, family heritage, or religious motifs. These details were integrated into the functional elements of the home, enhancing both beauty and identity without compromising structural integrity. In this way, the longhouse was not merely a shelter, it was a cultural statement, a symbol of continuity and communal memory. As storms swept over the fjords, waves crashing against rocky shores and snow swirling through forests, Viking homes stood firm. Timber flexed under pressure, roofs shed weight efficiently, and walls absorbed wind without splitting. The lessons embedded in these structures extended beyond survival. They demonstrated a profound understanding of forces, materials, and environmental adaptation. This knowledge, accumulated over generations, allowed a people often remembered for raiding and exploration to build enduring communities in one of Europe's most challenging climates. The legacy of Viking architecture continues to inform modern understanding of sustainable and resilient building. Their emphasis on local materials, energy efficiency, and integration with natural landscapes aligns closely with contemporary principles of ecological design. By observing and accommodating natural forces rather than resisting them, Vikings created structures that could endure centuries, illustrating that true resilience lies not in rigidity, but in harmony with the environment. The longhouse was both practical and symbolic. It represented the union of human skill, communal knowledge, and environmental awareness. Each beam, wall, and roof element contributed to a system designed to endure storms, protect inhabitants, and provide comfort in an unforgiving climate. The principles behind its construction, adaptation, observation, and integration remain as relevant today as they were a millennium ago. As the sun rises over a quiet village, the outlines of longhouses stand against the horizon, smoke curling gently from their chimneys. The wind moves through the trees, brushing against walls designed to bend without breaking. Within, the warmth of the hearth radiates, a testament to the careful thought and centuries of experience embedded in every timber and turf layer. The Vikings' homes were more than shelters. They were enduring lessons in resilience, ingenuity, and the deep connection between people and their environment. Across fjords and forests, from Norway to Denmark and beyond, the architecture of the Vikings continues to inspire. Builders today study the surviving foundations, the layout of ancient settlements, and the techniques recorded in historical sources, seeking to understand the logic behind these extraordinary structures. The longhouse, with its combination of simplicity, flexibility, and environmental intelligence, stands as a timeless model of sustainable construction, a reminder that human ingenuity can create lasting shelter even in the harshest of conditions. Viking architecture reached its highest refinement in the subtle details of craftsmanship, where every element of a house served multiple purposes. Roofs were constructed with overlapping beams that worked in tandem with the walls to create a self-stabilizing structure. In some northern settlements, builders added secondary crossbeams beneath the roof to reinforce joints against strong winds and heavy snow. These beams acted as shock absorbers, distributing pressure evenly across the frame and preventing damage to walls or the roof itself. The precision required for such construction was extraordinary. Even minor miscalculations could compromise the home's resilience. The Vikings also mastered the art of modular construction. Some longhouses were built in segments, allowing parts of the home to be replaced or upgraded without dismantling the entire structure. This modularity extended to interior elements as well. Lofts, storage areas, and partitions could be modified as needs changed. The flexibility inherent in this design was particularly important for communities that faced seasonal population shifts, temporary visitors, or sudden environmental challenges. These homes were not static. They adapted alongside the people who inhabited them, responding to both human and natural demands. In regions where timber was scarce, Vikings turned to stone and turf. Coastal Icelandic settlements, for instance, often featured turf houses with thick walls of layered earth reinforced with stone foundations. These homes relied on the insulating properties of turf to maintain warmth during long, dark winters. Walls were sometimes sloped slightly inward, a technique that increased stability under heavy snow. Roofs were constructed from overlapping turf slabs, anchored by wooden beams or stone weights, which helped the structure withstand high winds. In these environments, Vikings demonstrated an ability to translate their architectural principles to entirely different materials while retaining the same commitment to durability and environmental harmony. Heating and energy efficiency were central to longhouse design. The hearth provided more than warmth. Its placement and design allowed for effective circulation of heat throughout the building. Smoke was not wasted but channeled to areas where it could aid in drying wood, curing fish, or preserving herbs. In some larger homes, internal flues and vents guided warm air to lofted sleeping areas, taking advantage of natural convection. Floors were often slightly elevated or layered with insulating materials to minimize heat loss. And storage areas for firewood were placed strategically to ensure both convenience and protection from moisture. The Vikings' approach to heating combined practicality with observation, maximizing comfort while minimizing effort and fuel consumption. Water management was another crucial consideration. Roofs, walls, and foundations were designed to shed rain and snow efficiently, preventing rot and structural weakening. Drainage channels, sloped floors, and elevated entrances helped direct water away from living areas. In coastal villages, where tides and storms could threaten homes, builders often constructed additional barriers, such as low stone walls or raised earthen mounds, to protect the settlement. These features illustrate a broader principle. Viking architecture was not just about individual homes, but about creating resilient environments capable of withstanding both daily and extreme natural forces. Regional variations in Viking homes reflected the diversity of climate and available resources. In Norway, longhouses were typically timber-framed with turf roofs, designed to resist cold winds and snow. In Denmark, where the climate was milder, lighter timber walls and thatched roofs were common, allowing for greater ventilation. Icelandic homes relied heavily on turf and stone, while Greenland settlements emphasized low, compact structures to resist Arctic storms. Despite these differences, core principles remained consistent: interlocking joints, flexibility under stress, efficient heating, and integration with the environment. The Vikings' ability to adapt their designs while maintaining structural integrity demonstrates a level of architectural sophistication that was both practical and regionally intelligent. Storage was treated with as much care as living spaces. Granaries were raised on wooden stilts or stone platforms, protecting grain from moisture and pests. Livestock shelters were positioned to take advantage of natural windbreaks and proximity to the main dwelling, reducing the energy needed to tend animals during harsh winters. The careful placement of these auxiliary structures contributed to the overall stability and sustainability of the settlement, reflecting a systemic approach to community architecture. Every building, every fence, and every pathway was part of an interconnected system, designed to maximize efficiency and resilience. Viking construction also incorporated subtle yet sophisticated aerodynamic considerations. Roofs, walls, and even fences were oriented to reduce wind turbulence and prevent uplift during storms. Pitched roofs allowed snow and rain to flow downward naturally, while overhangs protected walls from direct exposure. Villages often leveraged natural features such as cliffs, forests, and hills as shields against prevailing winds. These environmental strategies, developed over generations, created settlements that were remarkably resistant to storms, yet seamlessly integrated with the surrounding landscape. Even the simplest tools were employed with remarkable skill. Axes, adzes, and chisels shaped timber with precision, allowing beams to fit snugly without nails. Wooden wedges and pegs locked structures together, while rope and leather were occasionally used to reinforce joints temporarily during construction. Builders relied on observation and experience to judge the strength of materials, the fit of joints, and the optimal alignment of posts. The combination of skilled craftsmanship, local materials, and empirical knowledge produced homes that were both strong and flexible, capable of withstanding forces that might collapse modern, rigid constructions. Cultural significance was embedded in architecture as well. Homes were not just shelters. They were symbols of status, family identity, and communal cohesion. Larger homes often featured carved beams, ornamental gables, and decorative patterns, reflecting the social and spiritual values of the inhabitants. Even functional elements carried meaning. Placement of posts, orientation of the house, and choice of materials conveyed subtle information about lineage, wealth, and regional affiliation. In this way, Viking architecture was both practical and expressive, serving as a living record of cultural identity while providing essential protection. The durability of these homes was tested through centuries of harsh weather, warfare, and migration. Archaeological evidence shows that many longhouse foundations persisted for hundreds of years, with walls and roofs replaced periodically, but the core structural principles remaining unchanged. In some settlements, multiple generations inhabited the same site, reinforcing and rebuilding homes as needed. This continuity demonstrates a remarkable resilience, a combination of flexible design, durable materials, and careful environmental adaptation that allowed Viking communities to survive where less sophisticated settlements might have failed. The principles underlying Viking home construction offer lessons that remain relevant today. By focusing on flexibility, modularity, and environmental integration, Vikings created structures that could endure both expected and extreme conditions. Their methods anticipated concepts now central to sustainable architecture, using local materials, maximizing energy, efficiency, and harmonizing construction with the surrounding environment. Modern engineers studying these settlements often note the sophistication of designs that required no modern fasteners, concrete, or mechanical reinforcements, relying instead on observation, experience, and intelligent use of natural resources. The integration of natural materials extended to every component of the home. Stone, timber, turf, moss, straw, and animal products were combined to create structures that balanced strength, insulation, and resilience. Each material was chosen for its specific properties: timber for flexibility and tensile strength, turf for insulation and stability, stone for foundations, and straw or moss for filling gaps. The holistic approach ensured that no material was wasted and that every component contributed to the home's overall performance. As communities expanded, the principles of Viking architecture scaled to meet larger social needs. Longhouses were adapted to serve as communal halls, workshops, or centers for storage, while clusters of smaller homes formed protective villages. Villages were oriented to maximize sunlight, reduce wind exposure, and take advantage of natural drainage patterns. Paths and roads were carefully laid out, ensuring efficient movement while minimizing erosion. Even at the community level, the same logic applied. Resilient, adaptable, and integrated design ensured survival and prosperity. The aesthetic dimension of Viking homes remained subtle yet profound. Functional elements were often decorated, blending beauty with utility. Carved gables, engraved beams, and patterned doorways celebrated craftsmanship while reinforcing structural joints. Rooflines and wall patterns sometimes mirrored natural forms, reflecting a deep connection with the surrounding landscape. The homes communicated the values, beliefs, and skills of their builders without compromising the essential requirement of durability. Survival, comfort, and cultural expression were not mutually exclusive. Each home represented an intricate balance between human need, environmental challenge, and societal identity. Families, craftsmen, and communities invested time, knowledge, and labor into creating homes that could endure storms, resist decay, and provide shelter year after year. The enduring presence of these structures, whether in archaeological remains or in reconstructed villages, offers a window into a civilization that mastered both practical engineering and cultural expression in harmony with nature. The legacy of Viking architecture is visible not only in the remnants of longhouses, but also in the lessons it imparts. Modern architects and engineers can learn from the Vikings' use of local materials, flexible joinery, and environmental awareness. The longhouse illustrates that resilience does not require complexity, metal fasteners, or concrete foundations. It requires observation, adaptation, and an understanding of the natural forces that act upon a structure. The Vikings achieved this balance intuitively, producing homes that were as much a product of careful thought as they were of craftsmanship. By the end of the Viking era, these homes had become a testament to centuries of refinement. From timber-framed longhouses in Norway to turf shelters in Iceland and Greenland, the architectural principles remained remarkably consistent. Interlocking beams, modular design, wind-resistant orientations, insulated walls, and carefully maintained hearths formed a coherent philosophy of construction that prioritized durability, adaptability, and efficiency. It was a philosophy that allowed communities to flourish in some of Europe's harshest climates, and one that continues to fascinate scholars and builders today. The story of the Viking home is ultimately a story of human ingenuity. It is a record of a people who observed nature, learned from it, and designed structures that could endure its forces. Timber, stone, and turf were transformed into shelters capable of withstanding storms, snow, and wind, while providing warmth, comfort, and space for family and community life. Every beam, joint, and roofline carried lessons in balance, resilience, and adaptability, illustrating a sophisticated understanding of architecture long before the rise of formal engineering or modern materials. As a reconstructed village emerges under the rising sun, smoke drifting gently from chimneys and the wind moving through the trees, the ingenuity of the Vikings becomes evident. The longhouses, though simple in appearance, embody centuries of knowledge, careful observation, and practical experimentation. They demonstrate that true durability comes not from brute materials or rigid construction, but from adaptability, environmental harmony, and an intimate understanding of the forces at work in the natural world. The Viking home stands as a monument to survival, resilience, and cultural continuity. It reflects a civilization that understood its environment and crafted solutions that allowed communities to thrive despite extreme conditions. Across fjords, forests, and mountains, the principles they developed continue to resonate, offering a model of sustainable, intelligent design. The longhouse, in its simplicity and sophistication, remains a lasting symbol of human ingenuity in the face of nature's most formidable challenges. In studying these homes, one sees more than timber and turf. One sees a philosophy of living that prioritized observation, flexibility, and thoughtful adaptation. The Vikings did not merely construct buildings, they created enduring systems that balanced human need with environmental reality. Their architecture continues to inspire, reminding us that resilience, efficiency, and harmony with nature are timeless principles, capable of guiding human habitation long after the storms have passed and the centuries have rolled on.